Hello everyone, this is Yonggan from Georgia Tech. Today I will present our work, Losses Can Be Blessings, which aims at routing self-supervised speech representations towards efficient multilingual and multitask speech processing. We have witnessed an increasing demand for deploying deep neural network-based automatic speech recognition systems, or ASR systems, on mobile devices. However, the big data regime for training big DNNs is not always possible for ASR on low-resource languages, which prevents the wide applications of DNN-based ASR systems across the world. Fortunately, motivated by the advances in self-supervised learning, or SSL, state-of-the-art speech SSL models can learn rich speech representations via pre-training on large resource speech and then enable low-resource ASR via further fine-tuning. However, the prohibitive complexity of speech SSL models incurs serious efficiency concerns, which are especially severe for multilingual or multitask speech processing, as the speech SSL models are fine-tuned for each target language or task, leading to much increased parameters proportional to the numbers of tasks or languages. To this end, we propose the S3-Router framework, which stands for Self-Supervised Speech Representation Router, as shown in this figure, to process the input speech from different languages or tasks. Our S3-Router fine-tunes model connections via optimizing language or task-specific binary masks on top of SSL pre-trained weights. This is based on the insight that model sparsity can serve as a similar role as model weights to encode language or task-specific information while featuring much improved parameter efficiency as compared to standard weight fine-tuning. To achieve this, we formulate the binary mask optimization process as follows. Here, the theta SSL is the SSL pre-trained weights, on top of which language or task-specific masks MT are learned under an L0 sparsity constraint. To solve this optimization problem, the top KT elements in the mask are activated during the forward process, and all elements in the mask are updated via a straight-through estimator. Based on this formulation, a question is how to initialize the binary masks. Two intuitive choices are randomly initializing the masks or setting the mask values based on weight magnitudes. However, the former choice does not utilize any prior about SSL pre-trained weights, and the latter choice suffers from poor trainability, where the mask values tend to be fixed during the fine-tuning process. To this end, we propose an order-preserving random initialization to marry their advantages. Our mask initialization strategy randomly initializes mask values and then shuffle them to align with the orders of weight magnitude, which achieves boosted trainability and utilize the priors of SSL pre-trained weights. Next, I will show the potential applications of our S3-Router framework. First, it can serve as a new fine-tuning paradigm, and we interestingly find that discarding no more than 10% weights is all you need for SOTA ASR performance. For example, we apply S3-Router on WaveTrack 2 under different resources and observe that our method consistently outperforms standard weight fine-tuning in terms of the achievable word error rate. For example, a 2.34% WER reduction achieved at a 8% sparsity ratio on WaveTrack 2 base on top of Libre speech 10 minutes. This also indicates that the binary optimization on model connections instead of model weights can potentially reduce overfitting on low-resource speech. Consistent improvements can be observed under a cross-lingual transfer setting, where our S3-Router achieves lower phoneme error rate over weight fine-tuning across different languages from Cream Voice. In addition, our S3-Router can boost multilingual efficiency as it can simultaneously support the aforementioned 11 languages with a 88.5% parameter reduction. Furthermore, our S3-Router can serve as a SOTA ASR pruning scheme. We benchmark S3-Router with SOTA ASR pruning techniques, and we consistently observe that S3-Router achieves the most competitive pruning effectiveness. More benchmarks can be found in our paper. For the third application of S3-Router, it can serve as a tool to analyze what is encoded in speech SSL models. For example, we discover a high correlation between the mask similarity and the phoneme similarity of different languages, indicating that S3-Router can serve to analyze the encoded phonetic differences between languages from DNN views. Much more experiments and analysis are provided in our paper. That's all for the presentation, and welcome to our poster session. Thank you.